He give us a seems like furlough so that tomorrow is my work day. but I
Okay.
must but I must leave the meeting in this teaching collaboration at 9 a.m. Even though it is not my work day, but in 9 a.m. I have I have a meeting with a Ministry of Education.
Okay.
To get a pitching, Lustina. I get a pitching with Kidareka in 9 a.m.
Good
But
luck for you.
yeah, I mean, so miss you, Kate.
Yeah.
We have some in Indonesia. We have some grants from our Ministry of Education, kids. So maybe Dr. Inayati have some schedule with them like that.
Yeah, yeah, seems like that. Even though it's not my work day.
Okay. So good luck. Good
Yeah,
luck
thank
for
you, Kate. Thank you, Kate. By the way, after the teaching collaboration activities, I mean, after the activity with teaching, maybe we will have some meeting. We will have some meeting that you as our co-teacher give us some suggestion about the curriculum and etc. And also about how we can advance our teaching, especially in econometrics. Yeah, such I thought with you that we have two study program, economic development economics and economics education. Therefore, maybe you will have some suggestion for us as a co-teacher in this teaching collaboration activities, and maybe we will discuss about our curriculum and maybe about seems like
the material of our
materials.
Okay. Okay.
Maybe
Okay,
in another meeting, in another meeting with
with a great honor.
yeah, with some lecturer in econometrics. Hello,
Hi,
Vidya.
morning.
By the way, the student only 45 student. Where is the student? The student disappeared.
It's okay. They are just joining. No. They are joining during this lecture. It's okay, because it's normal. It's okay. Some of them are joining just later, so it's normal. Yeah.
Maybe because it is fasting day for us, and when our work day
Yes.
fasting day is not 7 a.m. but 7:30 a.m. Maybe it is because maybe it's some
Yeah. It's okay. It's okay.
okay. But I will, yeah, maybe Lustina and Vidya and me, of course, yeah. So notice the student to be join quickly because the activity will be hot.
okay. Okay, good.
And
Morning,
dear
Mrs. Vidya. Oh, sorry. Yes.
No, it's okay. It's okay. I interrupt you. It's okay.
No. Who is the master of ceremony today?
Sorry?
Mrs. Vidya, maybe.
Oh, Mrs. The master of ceremony today. Okay, Vidya will be a master of ceremony today.
Okay, good morning, everyone. I'm so sorry for coming very late and join with you very late today. Thank you very much for Ms. Inayati for the speech. And also thank you very much for Rustina. Thank you, Kate, for coming join with us again today. I guess this is our last meeting, right?
Yeah, it's okay. It's right. Yeah. Last meeting today.
Okay, so yes, and also good morning for the students. Yeah, I noticed that the students is reduced from the previous meeting, but it's okay. Maybe we can start the lecture while we are waiting for the other student. We will also notice for the other student who join with us today. Okay, so Kate, are you ready to start our class today, Kate?
Yeah, I'm ready. Yeah.
Okay. So everyone, let's start our lecture today. We will continue our previous materials about FAR. And today, Kate, we will continue the presentation about from the previous meetings. Okay, you can start now, Kate.
Okay.
Thank you very much.
Okay, I could start, right? Okay. Thank you very much. And yeah, today we have the last meeting. And first of all, I would like to remind some organizational issues. So I have two equipments. One is this one where you have video, and another one for Blackboard. So I will just, there are two of me in the meeting. So I will switch to Blackboard to just put some formulas and to remind you the story that we started to discuss last time. And because 1 week passed, and I think that some of you could forget the problem that we discussed. And also briefly, I will just make a conclusion about some steps that we have already made before it. And then we will continue discussing how I could check my estimations, how I could understand that all my estimations are okay, that they are just valuable and reliable, and that I could make some conclusions about some connections and correlations between these factors. So as usual, I would like to ask about the end time. So the same story like previous time, right? So we need to end till 9:15, right? For me to understand how I could organize my time here. Am I right? So 9:15, right? We need to end classes today. Okay. So
Yes,
let's
9:15.
Yeah. Okay. So let's continue right now, and just I try to check my Blackboard. Is it okay? Here, is it possible for me to share? Wait a minute. Okay, so yeah, here I try to share screen and to check whether I could do it or not. Yeah, I'm sorry, it's in Russian, but I will just wait a minute. I will check it. I will just fix it. Wait a minute. It's in Russian here. I did here. So wait a minute here. This is our last meeting where we just finished our meeting last time. So this is just wait a minute. I have 4 people waiting for entering. So I remind you what we discussed. We would like to find the dependence between 3 variables. So I will just remind you what we discussed here. So we said, okay, my central bank has interest rate. So from one point of view, I have interest rate. And I said, okay, usually interest rate is a tool, and this tool could influence and usually influences on 2 main variables important for the economy. I mean, money supply and CPI as inflation as price level. So I have money supply and price level as factors that are highly dependent from interest rate. And so I would like to check how interest rate could influence on money supply and price level. So we used VAR model, as we said. All these variables in macroeconomics, they are highly dependent from each other. So I could see that, for example, interest rate could be changed as a response for example, for change in inflation in my country. For example, country is highly dependent from import of entering different goods, buying different goods, and that's why my price is increasing, and that's why interest rate of central bank is also changed, because central bank try to manage somehow it. This is another story. For example, if I observe that money supply is growing from day to day, so it means that it could somehow influence on interest rate, because central bank try to control it, try to control commercial banks, and as well so try to somehow to manage with interest rate. and vice versa. For sure, policy of central bank influence on money supply and influence on price level. So all these factors, they are highly dependent from each other. And I would like to check for country, for Indonesia, for special period of time. So I also remind you that we had not so current data. So for money supply, we had data just in a minute. I remind you because I don't remember myself as well. So we don't have just current data. It's data that we have some period of time ago. So anyway, we try to answer the question, what is this dependence for us, for Indonesia, in terms of period of time that we take into account. So, and this is the goal. So last time we said that first step was to check stationarity for this time series. So first, maybe not this one is the first step. First step was to collect data. So we collected data, and we discovered there are different data sources where I could take this data, how I could export it in my Stata, and how I could use it further. And so this is a story. And next step was to check stationarity, and we discussed it. So we implemented Dickey-Fuller test. We found that these variables, they are not stationary, and that's why we just used a natural logarithm and differences of this natural logarithm, and again checked these variables again. So there was some steps, and first of all collected data, check stationary, and then do something with your variables to be sure that they are stationary right now. So in our equation, we used here not just usual variable, but here I remind you, what does it mean for us? Rate t for us, I remind you, mean that it is natural logarithm of rate. For money supply, it is natural logarithm of money, and for CPI is the same story. I didn't put here just I didn't put here natural logarithm because I try to save place, but still we keep in mind that we implemented natural logarithm and changes in natural logarithm here for solving the problem of stationarity. It was the idea, it was the main thing that we did. And then the third step was to use VAR without understanding, without estimations of a perfect VAR, of perfect lag definition. So we didn't try to find perfect lag lengths. We just used VAR, and we discussed a little bit our results, how to understand that variable is significant, how to understand that this variable influences on dependent variable. So we discussed how to read estimations, how to understand what does it mean for me, how I could interpret and explain the result I observed. So anyway, it was some issues here. So then a fourth step was a lag definition. So it was lag definition, and we also discussed that there are different tests to understand what lag length is most appropriate for your case, in your case, and consequently, for sure, we also discussed how we could include it in our model as well. I will remind you it right now in another screen, because I would like just to come back to presentation here. And here it is. I also remind you, what did we do last time? And first of all, let's start from the data and discuss the period of time that we used. So you see here, it was a money supply for, unfortunately, not for today, but till for Indonesia till 2017. So for us, we couldn't include, for example, rates and CPI for 2023 and say, okay, but I'm sorry, Indonesia money supply is only for 2070. No, it doesn't work in such a way. So we cut all data, and all data right now ended on April of 2017. Unfortunately, for sure, for us, it's more interesting to have a look on the modern situation, but the data for money supply cut all our variables, unfortunately, and we have to find some dependencies only till this moment of time. So again, we discussed a little bit this table because remember we said that we used natural logarithm there. As we use natural logarithm there, so we have the second equation, and here I have natural logarithm from the right side and natural logarithm from the left side. And it means that when I try to explain the coefficient inside of it, I said, okay, this definition means that if a variable x is growing on 1%, variable y is growing on b 2%. So this is our explanation, this is our specification, because we found, if you remember, that our time series are not stationary. And I'll briefly remind you what did we do when we just met last time. Oh no, sorry, it is for Apple and for stocks. So this is a problem that we try to analyze, and this is our first Dickey-Fuller test. And I remind you that we found that these time series, they are not stationary, and we need to do something, and we did. I also remind you that here we create new variables, and these new variables was for natural logarithm of interest rate, natural logarithm of CPI, and natural logarithm for money supply. And in this case, we also saw that we tried to somehow to examine, to check them, and we found, okay, the stationary right now, so they are okay right now. And also found that now I could work with them and I could implement a VAR estimation model. So then we briefly have a look on our final variables, and we didn't use histograms here because for us, we said, okay, we have Dickey-Fuller test, and it's obvious for us that now they are stationary. And based on this graph, we understand, okay, I assume that they are also stationary because I see 0 and they are just have some fluctuation next to 0, so it's okay for us. It's okay for us. And here is the equation for us. And we also discussed, and remember with Justina, we have discussed here the equation, and we try to write down it somehow. And I remind you the main idea: when you have such table with estimations, you have a look on, you have two choices, two options. You could look on the just interval, 95% coefficient interval. And if 0 is inside of it interval, then it means that you could assume that this coefficient is not significant for you. And if 0 is not inside this interval, it means that this coefficient is not significant. So you have a look on this part, and if 0 is inside of it, so for example, for force variable, for leg of money supply, 0 is inside of this interval, and that's why I could not just I couldn't assume that this variable really influence on rate. No, just I say, no, I don't take it because the coefficient before it could be equal to 0. So here in the interval, I could not see 0 inside. So 0 is not inside this interval. And that's why I could take this variable, and you see it here. I took these variables, and these variables really Wait a minute. You couldn't see my screen, I think. Okay, right now it's okay. Yeah. Right now it's okay. Okay, so, and again, I'll just briefly show you that, because I show it here and I understand, okay, I didn't stop my presentation there. So again, here briefly, IM2 for money supply for Indonesia for this period of time and for 2017. And this is a problem because we cut all data for immediate trade and for GDP. So here I had to cut and to decrease the period of time. And then what did we do? We used this table, and we remember that we had natural logarithm. And as we have natural logarithm, remember about stationary, that's why it will be easy for us to explain the variables, explain the estimation that we had. And then briefly, I discussed some results we already get. So first of all, we checked stationary with Dickey-Fuller test, and we found that our time series are not stationary, and we need to do something here. And again, here I did something. I used natural logarithm here, and after that, I used Dickey-Fuller test, and again I just see, okay, observe it. Okay, now it's okay for me. Now they are stationary, and I could use it for my VAR model. And also, as I mentioned today, I didn't use histogram here. I just asked Stata, and you could do it with this function. Wait a minute, with this function. You could do it with this function here, TC line, and if you use it, it gives you just lines, and it gives you some graphs, and you could see, okay, I suppose it is stationary right now, and for sure I have Dickey-Fuller test that also convinced me in it. I remember also last time, as I discussed, but you didn't see my screen, and that we also tried to build a VAR estimations model, and also discussed how I could write down my equations. So I remind you that VAR estimations give you results for some equations. So you have not only one equations, you have, for example, in our case, 3 variables and 3 equations. So you have estimations for 3 equations right here, and for interest rate, for money supply, and for price level. And here, to understand whether your estimation is significant or not, you just have a look on the interval. You have 2 options. You could have a look on the interval, and it's 0 is inside of it. So here you see 0 is inside of it interval. So 0 is inside of this period. I didn't take this variable in my equation, and you could see it right here. So I didn't use it. For first variable, for example, for interest rate, for change in interest rate, I have here the coefficient 0.55 and natural logarithm of my interest rate. And remember that table that I said you and before, we have natural logarithm, and we could explain it right here. As I remember, we also put it right down. You see it here. If interest rate increases, if interest rate last period of time, previous period of time increases on 1%, it means that during this period of time, it increases on 0.55%. So this is the explanation. This is how it works. So first of all, you need to understand what variables are significant, what factors and what variables are significant here. And after that, you will explain what does it mean for economics. And remember also last time when we discussed some estimation that we got for VAR model, I said that I see problem here. And honestly, when I got these VAR estimations, I thought that somewhere it is a mistake. Now, after all estimations, after all tests, post-estimation tests, I understand what these problems are. But now, for this step, usually when you are a researcher, you come through it with your own, and you have your own steps here. And I would like you to think in the same way. So it's not the purpose to got the results. It's not the purpose to got the estimations and say, okay, I'm happy I have estimation. No, it's not a story. The story is to understand whether they are reliable in the sense of macroeconomics theory or financial theory. So now we will try to figure out what is the problem. Last time, remember, we also discussed Lagrange criterion, and we said, first of all, I just used VAR estimations, and you need to do it because last function and last, not function, but comment, VAR-SOC in our sense of VAR-SOC is just comment that after VAR estimation allows you to give this Lagrange definition. So there are different criteria, and we discussed them a little bit last time. I also demonstrated you some formulas, but remember that the goal for us is not to understand mathematical issues. The goal for us is to implement all these factors and implementation of all these factors in practice. So here I see that the most appropriate Lagrange is 1, but in any case, if you have any problem with data, if you doubt in reliance of your of your estimations, you could try to put Lagrange for 2 period of times. It depends on you. I start from 1 period of time, and you see here, here is a comment. So I used VAR, and first it was a first variable interest rate, and then money supply, and then inflation, CPI in my case for Indonesia. And they said, okay, I define, and I found on the previous period of time that I have Lagrange for 1 period, and I asked the model to include here only 1 period of time, and we could see it. You see here it's only L1, because in the previous time we have also L2. L1 is responsible for Lagrange in 1 period, and it responds for 1 period of time. So here the coefficient, here are the coefficients for these variables. And in our cases for interest rate, we have a lot of factors that are significant for us. So you see here, I put their coefficient, and I could find that they are significant because coefficient interval didn't include, they don't include 0 inside. So the assumption that a coefficient is equal to 0, I could reject, and that helps me to include it in my equation. But stop doing it because we have one issue to discuss: order matters. I will show you it in the slide, and then I again switch to Blackboard because it's a little bit complicated. But what does it mean, order matters? You see here, we put some specific order, and we said, okay, I just assume that the most important thing here is to estimate rate and its dependence from money supply and inflation. But here is Cholesky decomposition. Don't be afraid. It looks scary a little bit on the slide. give me a minute and I explain you what does it mean. So don't be afraid, it's just a formula. But I just switch on my screen, on my second screen, to discuss with you what does this scaring formula means. So we have three variables, remember, and we need to understand and to answer the main question here. Unfortunately, I'm sorry, my previous my previous screen disappeared, and I need to put it again. So we have three variables: interest rate, inflation, and money supply. And I need to put them in the special order. To do it and to put them in special order, I need to answer the question: what variable do have a contemporaneously effect? What does it mean? So remember that we have a timeline. And here is, for example, time where we are here. And here is a CPI, here is the rate, and here is the money. So here is the period of time where we are. And if, for example, there is influence in the same period of time. So, for example, you have money supply and you have inflation, and if central bank change rate, it change CPI and money immediately. So if in this period of time we could observe the changes, so something happened here and it has an immediate effect on other variables, it means that we have contemporaneous effect. So if, for example, something happened here, I mean, for example, interest rate is changing, and at the same time we observe the immediate change in inflation and money supply, it means that interest rate is the most important and it will be the first. So if, for example, in my estimation, I assume that money supply, if money supply changes here, I will feel it and I will observe it on interest rate on the next period of time. How did I think about it? I thought in such a way. For example, central bank observed high level of money supply here. So central bank found that money supply is huge during this period of time. Then central bank think about it and change interest rate in the next period of time. So I assumed that money supply influences on interest rate in one period of time, not just immediately. And vice versa, as we discussed, I assume that change in interest rate influences on money supply and price immediately, because economic households and economic economic participants, economic stakeholders, they observe this situation, they understand that central bank changed money interest rate and they behave themselves another way. So it is immediate signal for them to change their behavior. So the same story with price level. I assume that price level here, if they changed in period of time T, so today, for example, central bank will just think about it a little bit further. So not in the immediate time, but further. Here, so to conclude in this period, on the step, I said that change in interest rate influences immediately on money supply and price level. So if interest rate changes, then money supply and inflation change as well. So they change immediately because of change in interest rate. If money supply change, it changes interest rate just in a moment, but try to do it as quick as possible. And the last but not the least, that prices changes just gives impulse immediate for other variables. So just I will give you, I will return back to that screen and show you here again this scaling formula. And when I did it, and when I did estimations, I remember that in macroeconomics there is a theory that prices in short-term period, they are fixed. And when I remember it, I understand that maybe I made a mistake when I put interest rate on the first place, because maybe it could be better to put price on the first place, because macroeconomic theory gives us understanding that price should be first. But still, for us, it is it is a purpose to demonstrate you all necessary, all tools and all other things that could be implemented here. It's not the purpose for us to do it in the most effective way and to publish our results. No, we are just discussing different methods of estimations and different opportunities that data usually gives us. So here we need to remember these things. What about stability? For sure, stationary somehow gives us hope that we will have stability conditions for our estimations. But there is another assumption, and this assumption deals with unit roots. It gives us, if you have unit roots in your equations or less than unit roots, or all your roots are inside of root cycle, it gives your system stability. What does it mean in usual explanation, not just in such a difficult explanation? It means that in short-term period of time, because later when you will discuss with your professors VKM model, for example, or if you decide to learn it with your own, you find that VAR model could be sometimes explained as short-term period equilibrium, I'm sorry. And that's why if you have short-term equilibrium, we assume that one day it will come to long-term period of time, a long-term equilibrium. And that's why usually they say that if you would like to be sure that your estimations are stable, you could assume that all roots, you could check that all roots and they are inside a unit root circle. If this model is not stable, what could you do? If it's not stable and if there are some roots that are out from this circle, then there is a problem. And then you could just, what could you do? You could, for example, try to include another level of lag definition. You could include another lag length, for example. And so it depends on you. You could do something, but you need to do something, because if you have some unit roots out of unit circle, it means that we couldn't say that we have stable situation. And here you could use a function var stable in stata after all var estimations. And here is modulus of all your how to say, of your roots, so all your definitions. And here you see that all of them lie inside unit circle. There are just 4 of them, and all of them are inside it. So it means that we could assume that our estimations, our coefficient, they are reliable, and all our dependencies that we found they are also reliable, and we could continue assuming that it works in such a way. So in our case, we observe that all inverse roots are inside of the unit root circle. So for us, now it's okay, and it means stability, and it means that if we are talking about VAR estimations, we are talking about short-term period equilibrium, and then if it happens, it means that we could assume that in long-term period, it also gives you some benefits and some additional profits for reliable. Still, I need to check autocorrelation as well. What does it mean, autocorrelation? Remember that sometimes I could observe that if I include lag, it gives me a problem in terms of error. And when I used lags of one period of time, remember we discussed that we have different statistics with different lag lengths, and I used lag in one period of time. I remember that I had options. I remind you these options. I had one lag here. You see here, some tests give me one lag and some tests give me two lags. Finally, I included one lag, but I keep in mind that I have the options to include two lags inside. And that's the reason why I need to check autocorrelation. And after that, if I have any problems there, I could rethink and change my mind and say, okay, I include two lags, because in case of one lag, I do have autocorrelation. So this is the reason why I need to check and to keep in mind that I could change my mind, I could change my opinion. So here again, I need errors. So errors help you to understand. If errors are not dependent from the period of time, from the previous period of time, then you could say that you don't have autocorrelation. What does it mean? Remember that we had error, and error includes all factors that I didn't include in my equation. So I didn't include a lot of numbers of equation, a lot of numbers of variables. I didn't include a lot of variables that also influence on interest rate, on money supply, on inflation, a lot of factors that I didn't include in my equations. So, but I keep in mind that they influence on all these variables as well, and they are inside of these errors. And errors, as I have time series, you understand that I have errors for each period of time. So for each period of time, for each quarter, for each month, I have error term. And if this error term depends from its previous level, so for example, usually for us, for researcher, it means that you didn't include in your equation something important. So you have some factors, for example, and they are important and you didn't include them inside your equation, and you start thinking, okay, maybe I missed something. It means autocorrelation for us. And that's why here I asked Stata to collect these error terms, so these errors for my model, and to put them on the graph. So here is error, and here is mean of the error. So it is quite close to zero. It's almost zero. And I say, okay, it means that all my errors, they are somewhere next to zero. Because if, for example, you asked program to give you the line of your errors, and if it looks like that, wait a minute, I demonstrate you the catastrophe, the problem and catastrophic situation when you could face in estimations of VAR model. And if, for example, you asked to collect errors, remember that, what does it mean, errors? I again remind you, we have rate level here. We have, for example, money supply here. We have money supply minus 1, because we have lags in one period of time, plus I had a natural logarithm of CPI, of inflation, and I had inflation minus 1 for period minus 1. Then I put here plus gamma 1 natural logarithm for rate t minus 1, plus some constant term, and plus error term. And here, after getting all these estimations, I could put them in the basic and use basic time series and calculate these ones. So I calculated this error. I define them. I define the level of these errors, and then I build the graph of it. I put the graph, I just draw the line, and after that, I just say, okay, how does it look like? And if my errors looks like that, so or something like this, for example, and here is the mean, and here is the 0, and mean, for example, is equal, for example, this variable. This is a huge problem for me, because it means that the lag length is incorrect for me, and I need to change something, because you see here is a growing trend in my error terms. It means that inside these error terms, there are some factors that I didn't include in my equation. So I didn't include it here, but it is significant and it has trend inside of it. And it means that, okay, it is growing, it's changing from time to time, and it is problem. So we are happy in our estimations, because we are lucky we didn't have such problem. And you see here our error terms, it is fluctuated just around the 0, and it's okay for us. We don't have any problems at all. So just this is a story. And for sure, sometimes when I try to look at a graph, I could make a mistake. And if so, I need to check it with some tests. So one case, if you make a publication and you would like to demonstrate your reviewer that you understand the sense of this test, you not just implement tests and read it and okay, forget about it. No, you understand what does this test means, then you need to really to just to have a look on their graphs and to understand what do they mean. So here there is a test that gives you such options. You could use var mar. So this function, I'm sorry, I missed L here. Here is a right writing here. Here is a right word here. And you see again, in case of one leg, I could not reject null hypothesis. So I don't reject it, and that's why for lag in one period of time, there is no autocorrelation at lag order. How do you understand that you don't reject it? How do you understand, could you reject or not the null hypothesis? You see here the probability that your calculations of your statistics of chi squared is higher than for table data is almost equal to 100%. So if this value is lower than 0.05, if this level is lower than 0.05, it means that you reject the null hypothesis. So in this case, we reject the null hypothesis in case of two legs in case of two legs, it means that in case of two legs, it means that I reject the null hypothesis because this value is lower than 0.005. If it is lower than 0.005, so then I reject this hypothesis. And in case of legs of two, there is autocorrelation. And this is the problem. And this is the case not to use legs of two period of time. But in case of one period of time, this value is higher than 0.05. It is higher, and it means that one leg is okay for me. And it means that, okay, I use one leg, and in this case, I could not reject the null hypothesis, and I don't have autocorrelation at all. Maybe we will make a small break here for me to understand some feedback from you, because a little bit I start to hurry because I understand it is our last meeting, and I would like to show just the finish. I would like to end these estimations for our model, and that's why maybe some complicated issues, and maybe you will help me to make some emphasizes. So just.
Okay, thank you very much, Kate. Before we take a break, 10 minutes break like usual. From what I learned from your explanation, maybe it's you could give us an explanation about after that, after we test is there any autocorrelation or not in our data? If there is, if the graph is just like you mentioned before in your screen, it's great news, right? Because there is no autocorrelation. But if something happened, okay, if there is an autocorrelation in our data, what should we do with that? Should we just drop it or change it because of just in FAR itself, we only do the research about that, that variables. So what happened if we have autocorrelation on that? What's the solution? That's maybe that's the first question. And the second question, if later the students want to apply these methods, is there any rules, or is there any, what we call it, something that we need to apply? What kind of variable that we can use in this method? Maybe that's for the students, yeah, for the knowledge of the students. What kind of variable that I can use and apply this FAR method in the future if I want to make a research? Maybe that's the point, because of this is almost the end of the explanation of FAR. So yeah, maybe the student needs new insight. Okay, so what can I do with my data itself?
Yeah, okay, I put all questions here, not to forget about it after the break. And for sure, we will start from this question. Thank you very much.
Yes, thank you very much.
Because it's very valuable for me to give this feedback. Okay, we will start from this point after break. Okay.
Yeah. Okay, we will start about 8:40. See you.
Okay.
Yes.
Okay, see you.
Okay, so everyone, we will have a 10 minutes break ya. Kita akan break dulu 10 menit. Kita akan kembali di jam 8.40. Tolong di sini, tetap di sini ya. Thank you.
Okay. Oh. Wait a minute, I need to switch on the light because I think it's quite bad. I'm too dark. Okay, so now it's better, I think.
Yes, okay. Welcome back.
So we could, yeah.
Okay, okay, so we will continue our class, yeah, after the 10 minutes breaks. Okay, so student, let's continue the Kate class today. Thank you, Kate.
Thank you very much for questions, and let's just discuss them. So I put some ideas here, some ideas about question of the year that you asked me. So first of all, it was a question about autocorrelation. And the second was about variable and about type of variable, about some problems that could be used with VAR estimations, and how, if I'm a researcher, how I could understand that I could try to implement a VAR model. So if you are not doubt, I will start from the end, and I will start answering from the end of the list. So I will start answering the question about what type of variables and how do you understand that in this case I could try to implement VAR estimations, and this no, it's not appropriate here. And then after that, I will answer the question what I should do if I do have autocorrelation, if I'm not so lucky, and the graph of these error terms looks like this one, for example, so growing trend or declining trend, doesn't matter. So anyway, I found inside the error problem, and what should I do? So start from what data and how could I understand that I could implement VAR estimations. Always when I make research, first of all, I ask myself, what is the problem? So what I would like to analyze. In our case, we answered this question, we said, I would like to analyze macroeconomic policy of Indonesia. I would like to understand how interest rate depends on money supply, how interest rate depends on inflation rate, how central bank answers to these impulses, how central bank makes the decision. This is a problem I would like to answer. After that, I say, okay, what is the data? So I have a look on the data. I understand that there will be one country in my sense, so I would like to analyze Indonesia. I would like to make the analysis of this country. I would like to analyze it. I would like to focus on this country and this policy. So I will have one object. So one object for me, one object, Indonesia. And after that, I think, okay, and what is about data? And remember we said, okay, I see, I have CPI, I have money supply, and I have interest rate, and all of them change over time. So you have data that change from period to period, and you have one object. So one country, one company, it doesn't matter, one object, and many period of times. In this sense, you may, and usually you do implement VAR estimations because you have one object and many periods of time. Again, we could make this table for us, for example, how to choose, how to understand. Here is number of objects, and here is period of time. In cross-section, for example, in cross-section, you know that you have many objects, for example, many companies, many countries, you have many objects inside your analysis. And you have one period of time. So 1 year, 1 month, 1 day, it doesn't matter. One period of time and many, many, many objects, countries, companies, I know others. It could be anything. So time series, we discuss them. We have one object and many period of time. More period of time you have, better will be in other the better will be your model. So time series, one object and many, many periods of time. And for cross section and for time series, sometimes I need to have many objects and many periods of time. There is another model, it's called panel data analysis. And usually it is just more complicated, and usually students learn it, for example, during second year or third year of studying econometrics. It's more complicated. But here is the difference. When you have a problem and when you understand how you could observe it based on real data, when you understand what is the period of time and what are the objects there, then and after that, you could understand, okay, what should I implement? Whether it will be cross-section analysis or it will be time series analysis. And this is the main issue that gives you the answer, whether it will be cross-section or it will be time series. And for sure, in cross-section, I don't have such problem as autocorrelation. I have another heterogeneity there because there are different objects inside and they have their own features and they could differ from each other and they could give this heterogeneity inside of it and could make your estimations not so good as you expected. But for time series, it is another story because here I have error term, and error term includes inside other omitted variables, so variables that you didn't include in your equation. And if they are very important, for example, I didn't include in interest rate, for example, I didn't include GDP growth. For example, in our discussion, we said, okay, rate could be influenced by GDP, by CPI, I'm sorry, and by M2, money supply. But we didn't include, for example, GDP growth. But it matters for sure. If your economy slow down, and for example, if your economy decline, usually GDP declining, usually your government and your central bank try to support the economy, try to decrease interest rate, but we didn't include it. And we said, okay, it is an error term, it is there. And if, as we discussed, it is important, and if when you try to make graph for make line for your error terms, for example, like here, and you find, oh, there is a growing trend here, and I have the problem of autocorrelation of my errors, what should I do? You don't need to deny this modification. First, that you could do change log length. It is the easiest way, change log length. Remember, in our case, in the table, there is options to use one leg or to use two legs. And the first and the easiest way to solve this problem to change the log length. So if you included one leg, for example, leg for one period, try to include leg for 2 periods of time. So change it. It may help. If it doesn't help, then think about additional variable. So don't say no to your idea. Just think about what should I add inside of my specification, inside of my equation, and to solve this problem. And again, there could be different things you need to remember. First of all, these things, they are about if I understand why my error doesn't work good as I expected, and if I include, for example, GDP growth, how it could help me how I could find the data. Because if you have a great idea and you face with troubles with data, sometimes you could use some proxy of variables that you would like to include because you fail to find these variables themselves. So this is two ways to try to solve autocorrelation. So change lag length, for example, in our case, if period of time for one period of time, for 1 month, there will be a problem. Okay, I say, okay, I include a second period of time, second lag length. And the second option here is to think about additional variable and to include it inside the equation and say, okay, I try to make it somehow. So this is the option that I usually use when I estimation VAR models. So I hope that somehow I answer the question and maybe it's a little bit clear what we are discussing. So maybe while you're thinking, I will try to, because I'm open for questions, and maybe if as today is the last meeting, we will just leave 10 minutes for questions or for comments, because maybe there are some additional feedbacks that we need to discuss. And I will still hurrying to give you more information and more details, because I understand this is my last chance to do it. And okay, so here is, we discuss, so if you have problems here, for example, if here will be 001 problem, then you say, okay, and leg 2, and you take leg 2. But you have a problem for leg 2 here, because remember, there is no problem if this value is higher than 005. This is lower, this is higher, so there is no problem for 1 period of time, and there is problem for 2 periods of time. So now I have options. Remember, because archaic test and a quick test give me options to choose 1 leg or leg for 2 periods of time. And now everybody is interested in impulse response function. Here's examples. I will just tell you in a minute how you could build them. For sure, if we don't have time to analyze them in details, I will send you presentation. You do have my presentation. And further, there are some comments. You see here is comments in VAR Granger that helps you to understand the right order and how to build impulse response function. And maybe I will switch on, not on impulse response function right now, but for order, because it is more important. I think we mentioned it already. And if you are interested in impulse response function, is only one comment in Stata, and it's quite easy. But for understanding the right order, it's a little bit complicated. Because remember, we said if I had 3 variables based on Cholesky decomposition rule, I need to understand what is the first, what is the second, and what is the third. How could I do it? Usually, Granger causality tests help you. And the question here is following. So, does lag of one variable helps to make the focus on another one? So here is the table, and this is the equation. So change in rate. So here is a interest rate of central banks, and here is a variable that we test whether it influences on rate, whether it helps to make the focus of this equation. So the first the first line is about whether money supply influences on interest rate, whether money supply, lag of money supply, helps researcher to forecast what will be the policy of central bank, whether money supply helps you to make the forecast how and what will be the level of interest rate in your country. So does lag of one variable, in our case, we are talking about money supply, because we are discussing the first line, helps you to make the focus of interest rate. So in this case, again, I look at p-value here. And if p-value is less than 0.005, the variable helps to make the focus of dependent variable. So in our case, we see that money supply helps to make the focus of interest rate. Inflation rate helps to make the focus of interest rate. And all them together, so if I have a look of money supply and inflation, both of them helps to understand the policy of central banks. If I'm going further, here you could read some explanation, some boring explanation, but I try to give you this explanation based on our examples, because I think when you discuss examples, it helps, because you understand, okay, I understand how it works. So here, rate and inflation, I would like to understand how rate helps me to make the focus of money supply, how change in prices help me to make the focus of money supply. And in this case, I see the answer. Okay, interest rate, the policy of Indonesian central bank helps me to change money supply. The level of inflation, the level of price in my country doesn't help. So it doesn't help to predict money supply. It doesn't influence money supply. And it means, if I'm going here, that money level should be the first, because we see here in Granger causality test that price doesn't influence on money supply immediately. It needs time to find this definition, to find this dependence between them. And the last story for money again, and we see that, okay, money here influence, not money, sorry, in inflation. For inflation, we said, okay, interest rate influence on level of price, money supply influences on level of prices, and all of them together also influences. And if I try to understand how each variable influences on other variables, I have a look. Okay, for money, for example, money affects interest rate, but here is a blue line. Why blue line? Why no green line? Because you see here is always 0, and here is 0.01. So it means that in 1% probability, there is a mistake in my explanation, that there is 1% of probability that money supply doesn't influence on interest rate. So this is a probability, still it's not equal to 0. In this case, it's equal to 0. If I take interest rate of central bank and have a look, okay, let's have a look here. Interest rate influences on money supply, and interest rate influences on inflation level. And in this case, I put it here and I say, okay, green lines, interest rate influences on inflation, influences on money supply. It's okay. And the last and the least, I think, I take CPI and I take inflation and I have a look in this table. Okay, and what about inflation? Inflation in this case influences on interest rate, influences on money supply. No, I'm sorry, not influence at all. So that's why there is a yellow line here, yellow thing here. And that's the reason. And you see that interest rate, the policy of central banks influences on inflation and money supply immediately. That's why it should be in the last of the line when you put your variables in the line of regression. And then it should be money supply and CPI and the price level. And this is the right order. And if you remember, our order differs from this one. It was like this. So the rate was the first, the money supply was the second, and inflation was the third. And we found that we need to change them, to change the order. It looks like when you do it, first of all, you say, why I think I need to do it? Because I don't see the differences. You will see the differences. And if you don't see, you are a lucky guy, because in your case, it doesn't matter, but usually Cholesky decomposition really matters. So my advice to you to make Granger causality test, first of all, before the final estimations. And if I give just a little bit summary before the end, because I feel that I don't have opportunity to give you impulse response function, I give you steps, if I were you, and how I will begin to make VAR estimations. How and what should I do if I would like to make VAR estimations? For sure, you may look at some slides here that we didn't have time to analyze. Impulse response function, how could you make them, how you could explain them, because there are explanations on the slide. Anyway, I'm free for your emails, and you could email me. But now, when I have some minutes before your questions, I would like to give you steps. What should I do? What you could do if you would like to make VAR estimations model based on a material that we discussed right now. So again, I used my laptop, and I just give you some steps, some necessary steps, if I were you, how I would make these estimations. So here is first one. You collect data, you understand problem, data plus problem. Data plus problem. And after that, you Dickey-Fuller test, so stationarity. If everything is okay, you go next. If everything is not okay, you use natural logarithm, you use differences of natural logarithm, and usually it helps. So you again goes to 0.3. And then, first of all, you need, before log definition, before all tests, just do VAR, just do it. With bad order, with bad lag lengths, just do it. After that, after that, you use VAR-SOC log definition. Log definition. Usually you have options here, because some tests give you, for example, 2 periods, some gives you 3 periods. You keep in mind that you have options, for example, 2 periods and 3 periods. Okay, I think I try with 2 periods. Let's try with 2 periods and go further. But keep in mind that you have options here. Usually you do have options. Usually these tests give you different results. After that, you make, I advise you to give VAR Granger. Granger causality test. Why? Because it helps you to understand the order of your variables. So you will understand the order of your variables. After you understand the order of your variables, you make VAR with right order in 5, plus with right legs from 4. For example, I give here, for example, 2 periods. After that, you test autocorrelation. If everything is okay, I go further. If everything is not okay, you go to 4 and use 3 periods. And if I use 3 periods of time, remember you had 3 periods. And what if I include 3 periods and 2 periods of time? I go here and say, okay, I will try to use this one, 3 periods of time. Let's try 3 periods of time. If it doesn't still works, so if it doesn't work, you have, okay, I need additional variable. You think about additional variable, you think about specification. And after that, autocorrelation var stable. You make var stable and find that all your all your roots are inside unit circle. It means that you are stable. It means that your estimations could be used for a short-term period of time of equilibrium. And after that, you are free to, for example, analyze IMF impulse, IRF, I'm sorry, impulse response function to answer the question, what happens if, for example, price changes in 1%, what happens with policy of central bank, or you could do nothing because you have results already, because you have final results, you have estimations. And previous time we discussed how I could explain these estimations, how I could just explain them to reviewer, to my readers. So this is it var. So we have I think 7 minutes, and I'm open for questions. So maybe we will start these questions, because I'm really afraid to to spend your time, because I know that you have we need to finish at 15. Okay.
Okay, thank you very much. Okay, for students, is there any question for Kate? Boleh ya, kalau mau ada yang tanya ke ini Miss Kate, silahkan disampaikan. Boleh dalam bahasa Indonesia, nanti saya translate. Yuk, mumpung ada. Okay, I'm trying to communicate with student. If there are any question for you, maybe I can deliver for you.
Okay, sure. Sure, I'm just.
Ini nanti. Souvenir. If you, the students, if you ask Kate some question or one question enough, I'll give you souvenirs from our department. You can take it.
It's okay. It's okay, because sometimes I get question on my email from students. So it doesn't matter that they don't listen to us. It doesn't matter that they didn't take part. Maybe they are shy. Maybe they need time to think. So it's okay.
Okay. And, do you mind if someday, maybe in 1 or 2 months on in one semester, the student face the problem and then email you? Is that okay for you?
Yeah, it's okay for me. So we always work in such a way, because usually when we give econometrics course, students don't need it. They need econometrics tool further. It's normal.
Yes, exactly.
Yeah, the same story.
Maybe the problem will the student will get the problem later when they try to process the data. If now it's kind of okay, so the step is 1, 2, 3, 4, 5, and in fact, when they face the data processing, they will face another problem or mistakes.
Yeah, it's the same story for us.
Yeah.
So students always listen. Okay, it's obvious. I will handle it. And so feel free. I have email. Maybe if I'm just not answering during the day, I always try to answer in 1 and 2 days. Depends on some classes and etc. So feel free, and it's okay. I understand that you have questions when you start to implement something.
Yes, exactly. Thank you very much for your kindness, because the student will need it later.
Yeah. I know it. For Russian, the same story.
Yeah. So
They
I
need to
think for
advance.
it's quite a long story. Yeah. We take
Yeah.
for meetings already to talk about FAR, but we
Yeah.
still have like three steps that we cannot explain until now. That
Yeah.
are the gender causality and also the impulse response. Yeah, which are it's
Yeah.
also very important for us to know.
Yeah. Yeah. But still, you know, when I prepared for impulse response function, I tried to make these slides quite clear. So there are explanation inside and some comments. So an explanation, final explanation. So I hope that this presentation could help in somehow to understand what could I do. And still, if not, I'm still open for discussion. And impulse response function, it is like the result of your great VAR. So the purpose is to get great VAR, reliable, stable, with good estimations, without autocorrelations. If you do it, IRF is not response function is not a problem. It's just one button. And that's all.
There's still a long way to go after you find the best result on FAR.
Yeah. So the problems isn't during these steps: log estimations, stability, autocorrelation. And if you handle it, okay, impulse response function is so easy. And that's why I changed presentation a little bit. I just, okay, we missed it, but I would like to discuss Granger causality test, because sometimes I saw a lot of researcher when a researcher implemented only Granger causality test. So they didn't have goal to make a forecast. They would like to understand whether one variable influences on another one. Only Granger causality test. So Granger causality test is a very useful tool, and an independent tool could be used without any VAR estimations. And that's why I just start to tell about it.
Okay, maybe for the last question, before we still have 2 minutes left, what the biggest problem that we can face when we are in the Granger causality step? Is there any problem that usually comes up in that step?
You know, usually starter gives you any results. The biggest problem that you could have, that all tests gives you, you are great, you are excellent, but when you understand the estimations, you couldn't understand it. For example, you get the negative coefficient where you expect to have positive. So for example, you know that investment increases your GDP. You know, it is a rule. The higher investment levels, the higher GDP. But in your excellent VAR model, you have negative sign. It is excellent. Granger causality test is excellent. Lag definition is excellent. Everything is great, but negative sign. It is a huge problem. And the problem, I think that it is an addition, you need additional variable inside this model. But I think that this is a huge problem, because Granger causality, usually it gives some results to you. Any results, it gives you. VAR estimations gives you some results. And you could somehow change lag length or something else, but you will get estimations. The problem is when your estimations meet the reality. And this is the biggest problem.
That's the biggest problem, yeah.
Yeah.
Our expectation is just the same with the fact.
Yeah. And this is just what I spent so much time for these estimations, and this is a problem.
So
and,
if it's happened, if the problem happens, so that your solution is is to add more variables on that.
Yeah,
we can fix. We can fix that. Yeah.
And or eliminate some. Maybe you have a quite long equation.
Okay.
Or maybe sometimes a variable for example, S&P 500 for market gives you problem, because they are not normal disturbance here. So maybe some stock prices, some market portfolio prices, they gives you problem because macroeconomics factors doesn't like them. I don't know why, but usually such equations have a lot of problems. So maybe eliminate or add something. But bad thing that you need to start from the point again. start doing again. Yeah.
And that's right. We should start from the first step, and we
Yeah. Start from
like
the first,
take
return
step
back.
to do.
Yeah, you understand me.
That's the challenge, I think, yeah, in processing that econometrics. The biggest challenge is our patient to find the best result.
Yeah.
Okay,
Yeah.
thank you very much, Kate, for your explanation, and also thank you very much for the fourth meeting. Yeah,
Thank you very
we
much.
learned a lot from, about FAR. I hope these materials will help the students to understand FAR, which are most of the students will have the econometrics 2 on the next semester. So we will review, and maybe the lecturer can use your materials to recall what you explain in this semester. Thank you very much for joining with us.
Thank you very much. Thank you.
And also, I would like to say thank you also for the student, even though I think it's quite difficult for you guys today, but I hope maybe you can understand about this. And this recording of our meetings, our lecture for 4 meetings, we will upload it in the YouTube of our department, Ekonomi Pembangunan YouTube. Yeah, so the student can recall and also rewatch what kids explanation about the FAR. Okay, I think it's 9:18 already. This is the end of the last meeting today. I would like to say thank you to Kate, and also thank you for the students for joining with us until now. I hope we can meet again, yeah, Kate, in the next semester.
Me too. Thank you very much. Thank you for your feedback and for your support. And thank you for such opportunity, because it's a great experience. Thank you very much and good luck.
Yes, thank you very much.
Thank you.
Thank you, Kate.
Thank you.
Bye-bye.
Thank you. Bye-bye. Bye-bye. Bye-bye.
Oke, terima kasih semuanya. Semoga apa yang disampaikan Kate bisa bermanfaat ya. Oke, saya akhiri perkuliahan kita hari ini. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.